Hi students, welcome to the video. Today we are going to discuss about the implementation of polynomial addition. Here these are the two polynomials: 2x square plus 3x plus 5, 5x cube plus 6x plus 7. So these are the two polynomials. We are going to collect these two polynomials. First step is to define the structure of the program. So every linked list program structure is mandatory. You have to define the structure. Struct node 1 node. Here this is the structure that I am using here. In coefficient comma exp, these are the two member variables that we are going to collect. Then structure self-referential structure variable str use struct node star next. So these are the variables, and we are going to collect these two polynomials. So initially we need two linked list. So here I am using that two linked list for two linked list. For that we need two variables, star poly 1. So this instead of head I am using this variable poly 1, which is initially null. Then star poly 2, which equal to null, comma star poly third polynomial is to store the result, equal to null. Then after that, for creating a new node, I am using the variable p, comma for traversal I am using the variable q. So these are the variables, structure pointer variables that we are using. Again I am starting with the program. Void main. Inside void main, the first step of our program is to collect the total number of terms in each polynomial. So for that I am writing the printf statement. For that, printf enter the number of terms in first polynomial. So this is the first step that we are doing. Here we are collecting the scanf statement also. Scanf %d, comma terms 1, that is a variable that I am using for collecting the input from the user. So ampersand terms 1, int terms 1 is the variable that I am collecting. Okay, this is the first step. Once we collected the terms, then the next step is to process the value in a loop, because three terms we have in our first polynomial. We have three terms: first term 2x square, second term 3x, third term 5x power 0. So we have to repeat the process 3 times because the number of term is 3. For that I am using the for loop. For I equal to 0, I less than terms 1. So terms 1 is the number of terms and I plus plus. If this condition is true, then we are going to collect the number of terms here. So the first step is we are going to create a node for this. The step is p equal to malloc. P is the variable that you are using to create a new nodes. Malloc size of struct node star. So we are collecting this variable here, and first step is we are creating the node, and after that we are making the address field as null, because all the insertion should be at the end of the list, because first step is we are collecting 2x square. So 2x square will be the first one. second one 3x, and last one is 5x power 0. So each and every addition, that means if we are inserting a new term here, what we are doing is we will add the new term at the end, like this 5x cube is the first one, after that 6x, so that will be in the second position, and 7x power is in the third position. So each and every insertion can be done at the end of the list. So automatically I am mentioning p tends to next equal to null. So anyway we are going to insert the element at the last. So each iteration we are inserting the element at the end of the list, so that I am mentioning p tends to next equal to null. So then I am collecting the variable printf, enter the coefficient for the first term, coefficient for the first term. So first term in the sense this value is dynamic. So what I am doing is I am using the control string here, first term. Okay. In the scanf statement I am collecting this variable %d, comma, ampersand co is a variable that I am used to collect the value. So co has to be declared, comma co. Likewise ex also, ex represents the exponent. So printf enter the coefficient for the first term. I value is okay, %d term. So here what we have to do is I plus 1 term. Enter the coefficient for the %d term. %d represents I plus 1, 0 plus 1, 1. So scan of %d co. Then likewise I have to collect the exponent also. So printf enter the exponent of the %d term. So here it is ex. Okay. These two variables having the coefficient and exponent. That next step is to insert or add this value p tends to cof equal to co, cof equal to co, p tends to exp equal to ex. So these are the two values that we added in the node. After that the main step is we are going to insert the element at the end of the list. So first step, verify whether the list is empty. So for that, if poly1 equal to null, then we can confirm that list is empty. If poly1 equal to null, what we have to do? So two cases, poly1 not equal to null and poly1 equal to null. If poly1 equal to null, what we are doing is okay, if poly1 equal to null, then I am making the first element as the first element represented by the poly1 equal to p. So poly1 equal to p. Else, if the condition is false, that means if you are having multiple elements already existing, if the list is not empty, then what we have to do? We have to travel and find the last element. So q equal to head in the sense q equal to poly. So poly1 represents the first element, q equal to poly1. Okay, then what I am doing is while we are going to find the last element, q tends to next not equal to null. If the condition is true, then what we are doing is q equal to q tends to next, q equal to q tends to next. Okay, once we reach the last element, then what is next? Q tends to next equal to p. So insertion at the end also, that means the collection of polynomial details, the coefficient and exponent details of each polynomial is completed. So this is the first polynomial part. So what we are going to do is we are going to collect the second polynomial in a similar way. So here what we have to do is we have to copy the same. Okay, we are copying the same. Printf, enter the number of terms for the second polynomial. Second polynomial, term 2. Here I have to declare the second term. Okay. And instead of poly 1 I am using, so here also I have to make the changes. Coefficient, exponent. Okay, this is poly 2. So poly 1 and poly 2 and poly 3 are representing the first element of each polynomial. Here this also poly 2. Okay, so we collected the first two polynomial terms. So this is for the second polynomial and this part is for the first polynomial. Okay, next step is what? Okay,